Hey guys, how's it going? So, I think you should all be able to hear me now, and we're just going to get started. So, I'm going to go ahead and open up the solution that we were working on last time. And I believe we left off with basically, just a not square at all rectangle. So, we basically left off, sorry, let me get some water real quick. After vacation, it's hard to talk again. So we basically left off with like a square, and we have this being able to render and everything, and we have a logger up and running. So all that good stuff. What I want to get done today is basically combining several textures into one big sprite sheet on the fly. And I want to start getting some 3D stuff going. So we'll see how far we can get. Hopefully we can actually get there. And how's it going, guys? I just saw all your chat. Good to see you all. I'm glad you could make it. So, with the first thing that we want to do, we basically want to create a big sprite sheet. So I'm going to go ahead and just go to STB, image, because this is the easiest way to create images. So he's got like all of his different things in here, and I think he has one for writing images and for reading. Let's see. Yeah, so this is image loading, and I think this writes images too. So if we just take a look in here, let's see. And I think we already have this included. I just want to check it out real quick because I might need a different file. So, okay, right here. Basic usage, standard parameters, and yep, it's easy to use, all that stuff. That's good. Come on. I think he has it in here somewhere. No, maybe I'm looking in the wrong one. Let's see if he has a different file real quickly. So we've got image. Oh, image write. Okay, that makes sense. Cool. So we'll just grab this one, which is for writing images. I'm just going to copy that and then go back into here. And I think we have, let's see, Minecraft and then vendor. And I have STB right here. So I'm just going to go ahead and add another file in here. And we'll just call this stb write.h. And then I'll go ahead and paste all his stuff in there, which should be good. Yep. And then in order to get that to work properly, he says we have to define this. So we'll go into main.cpp, which I think I have somewhere in here. Yeah. Okay, so right below where we have this guy, I'm also going to do an undefined, because if you accidentally include this multiple times, then you'll get a whole multiple definitions error and all that stuff. So we'll just undefine that, and then I'll go ahead and copy that. And we can go ahead and just say define that, and then include stb/stb write. I guess I should call that image write, but it's fine. Okay, cool. So we should have access to a PNG or JPEG image writer. Let's see. So he says this is for writing images to C standard IO or a callback. The PNG output is not optimal. It's 20 to 50% larger than the file. It's written by a decent optimizing implementation, providing. And the reason I'm doing this too, because technically I don't even need to do this. I could just pack all the image together like in memory in the computer and then just upload it all to the GPU, but I want to be able to see what I'm doing and make sure that it's actually working right. So I'm just including this for testing. So, oh, and no cursor again. Thank you, Voxel Riffs. I will turn on the magnifier, which should, yep, I think you can see it now. Yeah, there we go. Cool. I need to find a better way to do that too, because like when I turn it on using the magnifier, it moves it for some reason. So like I have this all right here, and then if I were to do something in here, like it just moves my cursor randomly. I don't know if you guys can see that, but it's kind of annoying. I'll figure out something better though, or if you guys have any suggestions, that would be good too. Okay, anyways, so we just need this to do like testing stuff, and then once we have our testing stuff and we figure out it's working right, we can like move it so that it's all doing it just in like computer memory, and we're not actually writing any PNGs. Okay. But he says there's 5 functions. for each file format. So we can write PNG, BMP, TGA, JPEG, or HDR. We'll probably just do PNG because it doesn't really matter. And we have the file name, we have the width and the height, components, so RGB or RGBA, data, so just the pixels, and then the stride in bytes, so how big we have between each pixel. Cool. So let's go ahead and I'm gonna minimize that. So we've got include and source. I'll probably put this in utils because that makes the most sense. And I'm just going to create a new file in here. We'll just call this png helper.h. I don't know. Okay, so then inside of here, I think I'm using a namespace. Let me just double check that. Yeah, so we're using namespace Minecraft, so I'll just do that. So, got that, and then I'm basically going to create a struct in here. We'll call this pixel. So for each pixel, and this just needs an int x, y, and z. I don't know. Okay, so he says 5 functions with the file format. We need width, height, components, data, and stride and bytes. Is there a way to set what the data is? That's probably what we need to figure out. And I think Streamlabs does have an option for the cursor visibility, except every time I try and use it, it doesn't work on Windows. I'll try it again, like in my off time, and see if that works. It's not really that big of a deal, like the cursor moving and stuff, but I'll check it out and see if that works. Okay, so we've got all this. We can configure it with these global variables. So this is some other stuff. Okay, let's see. So this function creates an image file defined by the parameters. The image is a rectangle of pixels stored from left to right, top to bottom. Each pixel contains comp channels of stored data, interleaved with 8 bits per channel. Okay, so we need 8 bits per channel, and 1 is Y, 2 is YA, 3 is RGB. Oh, this is just for the components. So we should basically just pass in 4, because I think we want RGBA. And I guess this is if you want to do monochrome, and then this is something else. Okay, so the rectangle is width pixels wide and h pixels tall. The data pointer points to the first byte of the top leftmost pixel. For PNG, stride in bytes is the distance in bytes from the first byte of row of pixels to the first byte of the next row of pixels. Okay, so that's good information too. Then PNG creates output files with the same number of components as the input. Okay, so let's just do a test image real quick. So basically, I think we should be good to use like this. I think if I include, let's see. Yeah, that, and then that. I think I have like, I can do int 8. Yeah, okay, that's nice. Just because that's a little bit nicer. Pixels can only be what, like 0 to 255, right? And then 2 to the 8th is 255, I think. Maybe. Just going to double check that because I don't have confidence in myself. Okay, so we'll do 2 to the... Nope, that's wrong. Let's see if I can get this. Okay, we'll just do 2 squared, squared, squared. Okay, so that's like 2... I don't know. I think 2 to the 8th should be good. I can't do math on stream, I guess. Okay, so we have a structure of a pixel. We have XYZ, but I guess RGBA should probably be better. Okay. That should be good. And then the stride is going to be whatever width times size of pixel is, right? Yeah. So then if I wanted to create an image, if I go into main.cpp, I'm going to close out most of this stuff for now. So we'll just go ahead and we'll say we want to create an image. For now, I'm going to say it's 32 pixels by 32 pixels, okay? And this is width and height. Nope, can't do that. Okay. So width is 32. And height is 32. And 2 to the power of 8 is 256. Okay, cool. So that should still be good. Okay, so we have 32, 32. And I think 256 is what I want anyways because pixels can go from 0 to 255. So that makes more sense. Okay. So we're going to try and write out an image. And I'll do like first line is green, second line is red, third line is blue, just to make sure that I am doing this properly. So then we'll go ahead and we'll just say, what do we need to do? We basically just need to make some data. So I'll have an int star, and I'll say this is my data, which equals alloc mem. We'll say width times height times size of pixel. And I need to get that included. So we'll say include render, or no, I think I put that in util. Util slash png helper.h. Is it going to find it? Nope. Did it put it in the wrong directory? Let's see. Because sometimes if, wait, let's see. No? Okay, that looks like it's right. Sometimes in Visual Studio, if you don't click the right buttons, it puts things not in the actual directories, which is really annoying. But okay, let's see. What's wrong with this? Cannot open source file. That's right. That's right. I'm going to rebuild this real quick just to make sure I didn't mess anything up. So we'll just say build for VS 2019. That's all good. Reload. Nope, still can't find it. Okay, let's see. This is inside include, render. Oh, utils. That would help. Yeah, thanks, Pattinzol. I just noticed that. Okay, so there's like a lag between me and you guys too. So if I take a little bit responding to you guys, that's probably why. But we want to allocate that memory. And then I'll just say that's an int star. And that should give us width, height, times size of pixel memory. Cool. That's good. And then I'll say for int I equals 0 until I is less than width times height, I plus plus. And then we'll say pixel, and I'll get that by reference, is data I. Right? That should work. What's wrong with this? Oh, this should be pixel. That makes more sense. Okay, cool. And then I'll just say pixel.x or r equals 1, or no, 255, because that's what we decide. Pixel.g equals 0, pixel.b equals 0. And we'll do this if I is equal to, okay, I gotta think about this. I'm gonna do this in 2 different ways because this is a little bit easier. So 2 loops. So we'll say int x equals 0 until x is less than width, x plus plus. And then we'll say for int y equals 0 until y is less than height, y plus plus. And I actually probably want to do this the other way around because we want to go row by row, not column by column. So yeah, I'll just switch these up. So just copy that and then paste it there. Nope, not build it. There we go, paste it. And then this will become the x's. Okay, there we go. So then we'll say pixel. We can get I just by saying I equals x times width, or no, x times height plus width, right? Nope. That should be y times height plus x. Nope, width. Okay. I'm confident of that, okay? And why am I not using an index buffer? Oh, this is because I'm just writing a PNG right now. So we're just trying to write out PNG images right now, and I'm just making sure that I can generate images, because the plan is I want to basically get all the images inside of here, and I want to combine them into one big sprite sheet. And so I'm going to write out a PNG just to make sure that I'm actually doing that properly. So, okay. So we've got this pixel, and then we're going x equals 0, and then we get I by just expanding this by saying whatever column, nope. Yeah, whatever column we're on. Yeah. Okay, times width plus x. I think that's right. We'll find out. Okay, so then I'll say if y equals, or wad y mod 3 equals 0. So every third row, we'll do this. Else if y mod 2 equals 0, and y mod 3, well, actually I don't have to worry about that, right? Since I'm going, yeah, okay, we should be good. So basically every third row we'll do red, and then I can move this out. And then we can say every second row we'll do as green. Yep. And I need to move that up. Okay. And then every first row we'll do as blue. So I'll just copy that. And then change that to 0. Change that to 255. Okay, so if I think this is going to work right. So basically we're just going to go ahead and set all this data properly, hopefully. And then we're going to go ahead and use STB right to write this out. So he says we should be able to use this guy. So I'm going to go back into main and we'll say call this guy. And he takes in a write function. I think I missed what that was. Okay, let's see. Yeah, so a function, and he said the functions create the image, blah, blah, blah. Did I miss what write function is? Wait, let's see. Oh, okay, that used the arbitrary write function. Okay, so I think this is the one we want. Yeah, this makes more sense. Okay. So we'll use that one because I think that just uses the default write function, whatever that is. And I'll just say test.png. And then x is going to be width. Yeah, he said that's width and height. And then the components, we have 4 components, RGBA. Oh, I got to add in A2 to those. And then data is going to be, I guess we could just say the address of data 0 or data.r, which should give us like the first byte. And I think that should be good. Okay, and then, well, I did that wrong. The address of data 0.r. Okay, that should be right. Cool. And then the stride in bytes is going to be width times size of pixel. Okay. Fingers crossed this works first time, but I bet you it won't because I don't think I did that right. All right, so everything ran fine. That's good. Let's go ahead and see if we got test.png. That's good. And did that actually work? I'm very surprised if it did. Let's make it bigger so that we can see if this actually is working. So if I just make this 128 by 128, and if we actually add in pixel.a equals 255, this could still be broken too, by the way, because he might be expecting it in a normalized range from 0 to 1. So I could still have this wrong. We'll have to do a little bit more testing. But let's see. Okay, something's going really weird. Yeah, that got stuck. What did I do wrong? Okay, why is this telling me that 255 to -1? If we have int 8, we should have 256, but this is saying it's going to go to -1, so that's kind of weird. But it was working fine for that. Let me run this one more time. Maybe it was just a weird thing. Oh, there we go. Yeah, that's one of the joys of Windows, right? If you accidentally have anything clicked inside the command prompt, it just doesn't run for some reason. So yeah, make sure you click out of command prompt. Okay, I think this is working right. So we have red on the first row. Okay, and I think it's going from bottom to top because I wanted red to be every third row. And then green to be every second row and blue to be every third. Or no, first row. And oh wait, no, that's right. I think I see blue up there. Maybe. But anyways, it's going right. Okay, so we get red, green, and blue. So that's good. If I go ahead and just change this to whatever color this is, we should see something different. And we get a different color. Cool. Yeah, we get yellow in there. Sweet. So yellow, green, and blue. Okay, I'm pretty confident that this is working right. Not 100% confident, but we'll try one more thing. We'll read an image, and then we'll try and write that same image out. So if I say go to my texture class because I think I have an image reader in there that we can just steal for now. So let's go into the renderer and let's steal something in here. Yep. Okay, cool. So we load pixels here. Yep. And I'm just going to take that. And instead of doing this, we're just going to say this is blocks slash, let's see. Actually, I think I have the path here somewhere. Yeah, there we go. So it's block, or I guess it's assets slash all this. I'll just do the whole path. That's probably the safest thing. Okay, cool. So I'll copy that and we'll paste it in here. And then I think these are all 32 by 32. I might be wrong though. Nope, that's not going to tell me. Okay, so if we look at the details, yeah, 32 by 32. Sweet. So we'll just do 32. 32. What is this taking in? This takes in width, height. Yep. Channels and file. Oh, wait. No, this is going to tell me the width and the height, of course. Okay, so I got to do this. And then actually, this is probably better to be called WH. And then we just pass them in here. And he basically fills out that information for us. So we can do that and that. And then we can say channels. And that should be good. Required components. I guess we could say that's 4, but it doesn't really matter. We'll just leave that as 0. So this should get me pixels. And then we can say data right here. And instead of filling it with random stuff, we'll say get rid of that. And then we'll go const. Well, we can just say we're just going to write it out. So we just need this width and this height. I'll call this width and height, just that that's a little bit clearer. And then we'll paste it into here. And we'll paste it into here. Cool. So we get the pixels. We allocate the memory. And then we basically just want to write the pixels back out. If we can do this, then we should be able to make a bunch of images into one big image, right? That's the plan at least. Okay, so we go through the height, through the width. We get the pixel. And we can also get, let's see, we can get the pixel in there. So we can say unsigned char, which is just an int 8, raw pixel. And we'll say that is pixels I. And there's 3 components per pixel, so we probably want to do I times 3. That's what I'm thinking. And we're going to get the address of that. So if we get the address of that, then we can just say, instead of this, pixel.r equals raw pixel. Pixel.g equals raw pixel plus 1. And we want to wrap that in parentheses so that we're doing pointer arithmetic and not regular arithmetic. Pixel.b equals raw pixel plus 2. And then pixel.a equals raw pixel plus 3. And I'm going to do an assert here just to make sure. I believe we have RGBA in Minecraft textures, but we should double check that. So we'll assert that channels is 4, need 4 channels. Okay, cool. So if we do this, we should just get the grass block side if we're lucky. Okay, so that all worked right. We didn't get an assertion error. And if we go back into here, we go into test. Well, I can sort of see it in the background, but that is definitely not the grass block. We've got some weird RGB stuff going on. Okay, so what's happening there? So if we look into here, this says, yeah, stitching. I'm not sure when you wrote that, voxel riffs, but yeah, we're gonna be stitching the images together. So, okay. So, I'm guessing we're probably, I don't know. Okay, let me go back into here. Maybe I just made a mistake in here. So, oh, this should be I times 4. Okay, maybe that'll fix it because we have 4 components, not 3 components. I should probably just use channels there. You think that doesn't override, but writes on top. See, that's what... It did look like that because we had the red, green, blue, but if I... Yeah, okay. So since I was off by 1 and we were skipping every alpha channel, it was getting some weird artifacts in there because I think the alpha was just like, yeah, taking like 1 component. So it would be like 255 every now and then it was just being weird. But yeah, let's make this safer. That should have been channels all along. So what features do I have planned for this clone? I've been thinking a lot about it, and I want to get a pretty substantial Minecraft clone. So I want there to be like an inventory system. I want there to be sounds. I want there to be lighting, you know, all the basic stuff. I want biome generation. I want infinite worlds, a good UI. And I also want to create a system. So I've been thinking a lot about how I'm going to load like different types of blocks, like fence blocks and all that type of stuff. And I want to basically create a system where you can create a Blender file, and then you can have 3D objects, and you can associate that with a block ID, and then you can just do arbitrary shaped blocks. So it doesn't necessarily need to be even cubes. It can be whatever you create in Blender. And this is going to be something that I'm only working on during streams. I do really want to work on it outside of streams, but I figure it's probably best if I just stream it and then continue with the C++ series on the channel. And then once we get this to a substantial point where it's pretty much done, then I'll start doing tutorials on it, like formal tutorials on my channel. So the reason I'm only doing this on streams is because I think it's kind of cool to code this entirely on stream. So yeah. Okay, but with this in place, we should be able to start making our big PNG. So we basically want to get all the files inside of here. Yep. So non-voxel meshes also work. Sort of, yeah. That's what I'm going for. So basically, you can just load arbitrary 3D models, except it's considered a voxel. I might put some limitations on it, like it has to be 1 meter by 1 meter, or like by 1 meter, or stuff like that. But we'll see. I don't know. As we go in and we actually start experimenting with it, we'll see if it works good. And if it doesn't, then I'll scratch that. So, okay. So we basically have all this, I think. And these aren't consistently 32 by 32. We have some that are like bigger. Yeah, and see, I think they do something similar to that too, because they have this PNG file, which is clearly not... I mean, this looks like a UV wrapped image. So I feel like they're probably doing something special. I don't know. We'll figure it out. But we've got all these images, and we just want to stitch them together in the best way. So you would have said magical voxel models would do, so you can do some optimizations. I'm not sure what you mean by that. You should expand on that a little bit more. Okay, but basically we just want to create an image. I'm going to say, to make it simple, we're just going to get however many files are in here. And then I'm just going to take the square root of that and multiply that by 32, and that'll be our max width. So that should be good. Okay, so we can go and say, get all the images in here, get the number of files. And we need to loop through them. I'm going to use file system. I have my own file system thing, but this is the easiest way to do this. So we're going to say std file system path images equals, nope, not like that. There we go. And then I think we can just say like for auto image in images. Let's just see if this works. We'll say logger info, and then we'll say image dot path. Nope. String dot c string. Okay, and then we need to do %s. Cool. So let's see if this gets us all the images. If it does, then we can sort of go from here. Nope, that does not give it all the images. It just gives us the path parts. Oh, magical voxel is a tool. Okay, a model creation tool. Huh. Well, maybe we can. Yeah, we can make a whole tool to create the voxels and stuff. I don't know. We'll have to go into it. I think it'd be cooler to just use Blender and like import the exact model and stuff, but we'll see. Whatever works best is what I'll try and go with. So this did not do what I wanted it to do. It just gave me the path parts. Let's go to Google. And I thought I had this open. Maybe I closed it out. Okay. So we'll say std file system loop through files in directory. Yeah, so we've got a directory iterator, and we can just say, oh, we just have to get a directory iterator. Okay. So let's just go ahead and say this is std file system directory iterator images iter equals images path. I think I can just do this. Nope, that's not going to work. Okay. Dot iterator? Nope. Dot path? Nope. I should probably actually read the examples they give. Okay, so if we click back onto this. So this says create directories. Okay, so he's just giving the path directly in here. So I guess, yeah, I guess we should just do that then. I don't like doing that, but whatever, if that's what they're doing. So we'll just go and put this in here. And then I will go ahead and copy that and paste it over this stuff. Okay. So this should give us a directory iterator, and he said we can just do path dot cstring. I think we might need to do string. Nope. Yeah. We'll do string cstring. Okay, cool. So we can do that, and then let's run that, see if we get all the images in there. That's not working. Well, it is working. Okay, yeah, this is a weird thing with path. I don't get why it does this, but you have to do string dot c string. Otherwise, it just gives you the first part of the path, which is really stupid. Not a good API design in my opinion, but whatever. Okay, yeah, cool. So we got all of the stuff. Cool. So now we just need to count it and then figure out how big we should make the images. And is there a repo for this project on GitHub? There is. I think I just called it. What did I call it? Yeah, for the Minecraft clone. Yep. Let's see. So if I just go into, I think I put it in my regular GitHub. Oh wait, let's see. I got my password wrong. I don't care if my personal email gets up here. I don't think you guys are gonna spam me or anything, but okay, so if we just go to my repositories and I thought I put it in here. Maybe I didn't put it on this one. Yeah, okay, it looks like I might have put it on my other repo. Let's see. Or my other GitHub. So I think that's that. You get red for spam? Okay, let's see. Oh wait, no, I think this is it. I can't remember my usernames and passwords or anything, guys. It's bad. Okay, so if we go into repositories here. Yeah, stream Minecraft clone. Okay, that's what it is. Cool. So if you guys want to grab this and work with it and stuff, I think, yeah, this is a bad readme, so don't pay attention to that. But you can just clone this and then run build.batch and you should be good. Cool. Okay, so we've got all the images. I'm literally just going to count them. Let's see. Do we have a function for that inside of the standard file system? File system count files in directory. So we can get the directory iterator. Okay, so they're just using a standard algorithm. So you just have to count it manually is what it looks like. Yeah, that's stupid. Why do I don't get people. It's like all they're doing is this. Count equals 0. count plus plus. But then they use the algorithm, and if you're a new programmer or whatever, you're going to be like, oh, maybe that's faster or something. But no, it's literally probably just doing this under the hood. So, oh yeah, I'm using Opera. I was watching PewDiePie, and I was like, you know, Opera is pretty nice, and it has Discord and everything just built right in, which is super cool. So, I don't know. I'm experimenting with it. I've still got Google Chrome here because I kind of go back and forth between them. Okay, so we get a number of files, and we're counting those out. We don't need to log that because that doesn't matter. And I'm just going to make this... Well, we can't do that. Okay. I'm going to say const char star image path. And then we're just going to pass this in here instead of copying this every time. Okay, cool. I can't just use the same iterator because I think that's going to change as I iterate through it. So that stings. But basically, we get the number of files. Then we can estimate a width. We'll say max width equals square root of number of files. Cool. And that should do all the clamping and everything. Let's just log it to make sure this is working right. So we'll say max width, and then we'll give it the max width. And we need to multiply this by 32 because that's like the expected image width. Okay, cool. So let's see if this works out. So it says the max width should be 153. That does not sound right at all. I think I knew the square root of that times 32 times 32. That's probably because width times height. Okay, and then we get max width is 868. That sounds about right. So if everything works out, we should get a sort of squarish image in the end. Okay, so then we can go ahead and we'll say int current x equals 0, int current y equals 0, int line height equals 0. And we'll kind of use these to traverse through our image. And this is going to be tough because we basically need to get like how tall it's going to be. Yeah, I know this is in main.cpp. I'll do refactoring and stuff. I just want to get proof of concepts out, and then we'll refactor all this into its own thing and then go from there. Don't worry, this won't be a 5,000 line file, hopefully. Okay, so do we read every single image twice? Because basically, I could guess at what the height should be, but then we could be wrong, and then I would create an image that's actually not, or actually, well, this is tough. Let's do this. I'll have a list of int 8. Or actually, I'll just have a list of pixels. And this will be our pixels. Okay, and then we can dynamically grow it, and then we can write it out at the end. This is probably the best thing to do. And then I'll initialize this to max width. So we'll say list of pixel, and then we'll give it max width. Okay, and we have pixels twice now. See, this is why you shouldn't put everything in the same function like I'm doing. Okay, we're not going to need this anymore because we're basically going to be doing this several times over, so I'll comment that out for now. This should be images path. I just got to think about this for a second. Okay. So we've got our pixels. These are the pixels that we're going to be writing out. So we'll say for int file number equals 0 until file number is less than number of files. File number plus plus. And I'm not being consistent with my naming at all. This is num files. This is file number. We'll fix all this stuff later. Okay, so we're going to loop through all the files. Which I guess I don't need to do that. I should probably just do this. And then we basically want to write them out to our pixel buffer file by file. Yeah, I think I can press tab and stuff. It's just, I don't know. I've gotten so used to writing these things out for like manually. It just kind of comes naturally. And I like to think about that stuff too as I'm writing it. It helps me like clarify things a little bit more. But I'm trying to think about this because basically we have to write out these pixels row by row. We can't, well, No, we don't necessarily have to do that. Okay, so here's what we're going to do. So we have our image. We want to read that image. So we need to do this. So let's do that. And then we'll take this step by step. Okay, and so we are not reading this image. We are reading image.path.string.cstring. Okay, and then we get the width, the height, and the number of channels. We assert that we have 4 channels because we want to write out a 4-channel PNG. So that's all good. Then what do we need to do? We basically need to figure out what the height is. Okay, so we say height. So we've got the height, and then we'll say line height equals maximum of height and line height. Okay, so basically if we have a line height, or if we have a height that's greater than whatever picture we're on, then we set the line height to that height. Okay, so that should give us the height for this current line, and then we just want to make sure that we have enough pixels in our pixel buffer, so we can say, I guess we should do this in an if statement. If height is greater than line height, then we'll say line height equals height first of all, and then we need to get more pixels into our pixel buffer, right? So we'll say pixels.add .resize. I think I can resize it. But why am I not getting... Oh, I have 2 pixels, don't I? Yeah. This is the raw pixels. Okay, there we go. So we can say pixels.resize. And the new size is going to be line height plus line height. And now I have height multiple times 2. So we'll have to fix that too. Or actually, I guess current y plus line height times max width. Okay, so this should basically ensure that I always have enough pixels to write to our PNG, our fake PNG image, I think. So now if we have all this done, we can go ahead and say pixels, and we need to do XY. So we'll just say for int x equals 0. Yeah, until x is less than width x plus plus. And this is all getting really confusing. I got to rename some of this stuff. Okay, so we got max width, which is just the width of our PNG output width. That's what that is. So if we just replace that, and replace that. Cool. Current x is fine. Current y is fine. Line height is fine. Pixels. This is... Yeah, I guess that's fine. Okay, whatever. Yeah, that's fine. So we got width, height, and channels. We load the image, we assert, we get the line height, and then we resize if we need to. And then we're looping through. So then we'll say for int y equals 0 until y is less than height y plus plus. So now we're looping through the pixels in this image, and we can say pixels x plus current x. Okay, yeah, so this is what we're gonna have to do now. So then we can say we've got our current x and we've got our current y, and we basically want to figure out where we are in the global image, which is this pixels buffer, right? So if we think about this, take a sip of water real quick. Normally I would start drawing this out, but I just did some changes to like my office area, and I don't have enough cable for my tablet, so I can't actually draw on it right now, which is annoying. Okay, so basically though, I'm gonna draw it out anyways because I just can't do this. So let's get a marker up and we'll get some shapes. So we've got this giant image. We're looping through it and we're sort of incrementally building it up pixel by pixel. And right now, nope. We're say working on the first image, right? So that's the first image in this giant buffer of images. We've basically allocated enough memory to hold up to this much. So our image is sort of like cut off here right now, and then it'll grow as we get more images. And we basically want to figure out which pixel we're on inside of here. So our current X is pointing here. Our current Y is also pointing here. So we're pointing at the top left corner of this. Let's go a little bit further in to make this a little bit easier to conceptualize. Okay, so say we're right here, and then our current X should be right here, and then our current Y is still here, right? So that's current Y, it's current X. To find out which pixel we're in inside of here, we can do like, if we're here, this is X plus current X, and then this is Y plus current Y. Okay, so we can say local X equals X plus current X. Local Y equals Y plus current Y. Right? So that should give us the correct pixel location. And then to get to there inside of our pixels list, which is just one dimension, we just say pixel, current pixel equals pixels, local X, well, yeah, local X plus times max width, or actually PNG output width. That's wrong. Local Y times PNG output width plus local X. Okay. So that should give us the current pixel, and then we just want to copy the data. So then we just say current pixel dot R equals raw pixels, or actually I guess we should get the raw pixel too. So unsigned char star current raw pixel equals raw pixels, and this is going to be Y times width plus X. Okay, so same formula, and we need to get the address of that. Okay, there we go. Cool. So then we can just say current pixel dot R equals star current raw pixel. Copy that a couple times, and then we can change that to G, B, and A, and this should be +1, +2, +3. Okay, I think this should copy all the stuff we need. Now we just need to make sure that we set current X and current Y, otherwise we won't actually be moving our cursor, which is sort of this thingy, this current X, current Y. Because as we move along and finish an image, we should basically say, okay, now current X is here, now current X is here, and then once we move a Y, current Y is here, current Y is here. Okay, cool. So we can do that by just basically saying we have finished this loop, and we can say current X equals X plus, or actually we can just say plus equals width. Yeah, that works. Cool. And then we can say if current X is greater than or equal to PNG output width, then we need to increment our Y. So we'll say current Y plus equals line height, and then current X equals 0. Okay. If this magically works, we should get a giant PNG with everything. I'm not quite sure if that'll work, but we'll try it out. So by the end of this, we should have current X and current Y. So we have the width, we just need the height. So by the end of this, we'll have int PNG output height equals current Y plus line height, right? Because that's basically the very last thing that we've got. And so we can say this, and we can say output width, and our data is going to be located in our pixels. So we can just say pixels dot begin, and then we can get how big it should be just by doing this. All right, I don't think this is going to work, but we're going to try it anyways. So when's the YouTube series for this thing starting? Probably in quite a while, because I want to get this to a point where it's like we can at least run around and stuff. So we've got some like basic physics and world generation going. And then once I get it to that point, I think I'll be confident starting a YouTube series on it. And hopefully by that point too, the C++ series will be in a good enough point to where if anybody doesn't know C++, they can learn it. They can always use Cherno series and stuff too, because he's a great teacher and he has a huge C++ series. Okay, I broke something. So we said if height is greater than line height. How did this trigger? Oh, wait, no. I think this triggered. Yeah, okay, so we have channels equals 3, but we need 4 channels. Which image was that? That was... I have no idea. That was image.path.string.cstring. Oh, come on. Visual Studio, this is when I need you. Okay, let's go ahead and we'll do a logger info, and we'll say %s, and we'll say image.path.string.cstring. Okay. Let's retry this and see which image is breaking us. It is Acacia Logs, which only has 4 channels, or it has 3 channels for whatever reason. That's weird. I didn't know Minecraft had like some 3 channel and some 4 channel things. That's kind of weird. This was acacialog.png, which is this guy. Is this true? He has... No, it says he has 4 channels. So what is STB telling us then? Yeah, that is weird. So we get the image, we get width, height, and channels. Did I pass everything in right? So we said stbi load, channels and file. Let's just set this to 4. We want 4 channels. Maybe he'll automatically do something to magically make it work. Nope, we still got a problem. Inside of here. Yeah, I think it's the same thing. And it's still Acacia log. Okay. That is very strange. Let's see if Google has anything. STB image saying 3 channels with 4 channel image. No, that's a right. Let's see. So when I use to load 3 channel BMP images, it gives me 4. Okay, he said he fixed that, so that shouldn't be a problem. Let's look for channels. Okay, so this says outputs the number of image components. Whoops. Outputs the number of image components in an image file. The number of components n is desired channels. If desired channels is non-zero or channels in file otherwise. If it's non-zero, that would have been output otherwise. Okay, so if we set it to 4, we should always get RGBA output. Okay, so he's still going to output 3, but it shouldn't matter anyway. So I should be able to just remove this, and we should be good, hopefully. Okay, almost. Now we've got a bug in my allocation. What's this saying? Okay. It doesn't like me reallocating memory for some reason. I wish it would tell me why. Let's see. This all looks good to me. See, these are the kind of bugs that are just annoying. So I guess let's use standard list. Let's see if they have the same problem. So I'll go ahead and just say hash include list, or no, I need vector. And then we'll change this into a std vector of pixel. And then std vector of pixel. And I think this should do the same thing. Okay, so that says the count. I'm just gonna leave that as 0 for now. And then we basically just want to do pixels dot begin dot r. There we go. And then we just want to get the address of that. Okay, let's see if this works. Nope, I still get a problem. Okay, so it probably wasn't my library that was the problem. It's probably because I'm reallocating bad memory or something. I don't know. So we got pixels here, and then we basically just say resize. Let's undo all that. It makes me feel good when my library puts out the same error as the standard library, because that makes me feel like my library is probably working and I'm just making bugs in my actual program. Okay, let's put in a breakpoint here because I think this is where things are breaking. So if we run this, okay, that's fine. Okay, so the second time we try and resize, it doesn't like it. And what are we resizing to? Maybe we're resizing to a bad size. Right here? Nope, right here. Okay, so we're trying to resize to what? Actually, I should probably be in here. Okay, so this new size is 111104, 114576. Okay, so I think that's less than that, right? 111. Okay, that has 1, 2, 3, 4, 5, 6 digits. That has 1, 2, 3, 4, 5, 6 digits. Yeah. So we shouldn't even be entering this thing, I don't think. Your net doesn't want to cooperate. I'm sorry, voxel riffs. My program doesn't want to cooperate, so I guess we're kind of in the same boat. Let's step into this. Okay. Okay, so apparently that number is bigger than... Okay, yeah, so that number is bigger than that one. Cool. So then we're resetting the max size, and then we're reallocating that memory, and then we're triggering a breakpoint. Am I just running out of memory or something? I don't think I'm trying to allocate that much, am I? Okay, let's try this one more time. So we go into here, go into here. So what is M max size? So we've got that. That's in bytes. So divide by 1024 should give me kilobytes. Okay, yeah, so that's only 111 kilobytes. So that definitely shouldn't be like an out of memory thing. And I think our data is fine. Yep. No, it looks like our data is not fine. This is weird. Okay. So if we do mdata 0, that is giving me negative 122, negative 122. Oh, I think that just looks wrong because I'm using int 8 instead of uint 8. Okay. This should be unsigned. Now if we do this again, hopefully this all works properly. So we'll step into this, step into that. Okay, yeah, so we're getting 134, 134, 134. So I think the data is fine. Let's see what this address is and actually look at it. So I'll copy that. Whoops, nope, copy that. Paste it into here. And Where was that? That was 280 for something over here. All this data looks right, so I don't see any problems over here. I think this is the image. Yeah. So maybe I'm copying invalid memory or something. Oh no, this is just really weird. These are the types of bugs that make me not want to go back to programming. Just kidding. I would still program anyways. Okay. So there's something wrong with realloc. Let's see if that's the problem. Realloc throwing exception. Okay, so you need to reallocate first, then add a new element. Okay, so this guy is just using it wrong. Yeah, so that all looks right. Nope, that's not good. See, most of these problems are going to be like people using it in a way that you shouldn't be using it. Wait, okay, here we go. This looks like he's using it right, but he's not. Oh, he's saying you shouldn't use the same pointer. And then you should assign it afterwards. Okay, so I don't think that's the problem though, because this failed with the standard list too. So if we go into here, yeah, I'm just sort of doing it all at once here. Let's go ahead. We'll say t star temp equals that. If temp m data equals temp. Alt logger assert. Or actually, I guess I could just do error. Invalid memory allocation. Okay, so this should basically just make sure that the allocation succeeds, but I think we're going to run into the same problem anyways. We'll see. Yeah, typical programming. It's never just, oh, this works first time. Okay, let's see. What's going wrong now? Yeah, so we're still getting the same problem here. It's just not liking this. Let's try this, because I don't know what the heck could be going wrong here. Instead of doing this, we'll say this equals alloc memory. And then we're just going to do size of t times that. And then if that succeeds, we'll say, we'll copy it. So we'll say memset temp to m data size of, ooh, we need the old max size. We'll say old max size. And then here we'll say int old max size equals m max size. So we'll just copy the data manually. Yeah, I think that should work. Actually, I should probably use memcopy, not that. Okay, so then we'll say temp, and this could take data, and this could be old max size times size of t. Okay. And then we do that, and then we'll just say free memory m data. Or I guess we should say old data. So then we'll just do old data equals m data. Okay, we swap the pointers, and then we just free the old memory. Okay, let's see if that works. Can I please make the font size a little bit bigger? Yes, I will do that after I build this. Okay, I completely broke that. Is that a little bit better? Let's see. Going back down to check resize. Okay, so I say the old max size is whatever it is now. Then I say max size is that. Then I allocate new memory. And then if that allocation succeeds, I say copy the old data to the new memory location. And I give it that size. And then I say the old data is the old data. And then I say the data now equals the new stuff. And then I free that old data. That all looks right to me. Okay, but now this is broken. Yeah. Okay, because M data is null. Well, that should have thrown an exception then. Okay, check resize. Let's jump into that. Yeah, so I say if temp, I guess I should say if temp does not equal null pointer. Let's see if that works. Oh, maybe I am getting an error too and I'm just not seeing it. Nope, no error. Just that, but it's saying that is null, so that's really weird. So, okay, we do this. I'm going to put a breakpoint in here. Let's see if we're doing this all right. Okay, so we get old max size is 0. And new max size is 2. We allocate new memory. Oh, and then that breaks. Or did I press the wrong button? Okay, let's go. Let's do this one more time. Okay, so then we allocate new memory. Okay, and then it breaks. That is really weird. Let me try that one more time. This is just allocating memory. I don't get what's going on here. Okay, so we say allocate memory. Oh, okay. And I'm breaking within my internal checker. This is turning into a big headache. Let's go back to the standard library and see if that works. Even though it didn't. Okay, so let's go back. Hash include vector. And I'm going to turn this back into a std vector. And we'll see if there's something else that I'm doing wrong. Okay. Change that back to R. And that is the address of that. Okay, cool. So we got this vector. We just want to fill it. Let's see when this breaks. Okay. I'm just going to ignore that for now. That's going to break anyways. Let's revert this back to what it was before I started changing things. Okay, there we go. Rerun this. So we get this, and it breaks on the first one. It says vector subscript out of range. Let's try this again. So if I step past that, that's fine. I swear, if it was just failing, okay, I think I know what happened now. So I think we resized it, and then right here we wrote out of bounds memory. And then when we try to resize it again, it's trying to copy memory that was written invalid, which then throws an exception that I couldn't catch. Okay. So if we go far enough in this, I think one of these calculations are wrong. Which one is it though? I have no idea. Let's throw a breakpoint up here. If I continue. Okay, X is 1, 2. Yeah, this is the old-fashioned way. I'm just going to find where it breaks and then see what I'm calculating wrong. This is just like the most exciting programming that you guys have ever seen. So do you guys run into bugs like this too? And then it annoys you and you're like stuck on it for an hour and then it turns out to be something where you were just multiplying something wrong. Because I feel like I do this way too often. Okay. Well, that one worked fine. Cool. So maybe it's not even this picture. It's just something in here. Yeah, so it seems like most everything is fine. And you know what I think it is? I think it's probably this thing right here. And yes, that is one of the joys of programming. And yeah, no memory errors if you're not writing in C++. Actually, you can still get some memory errors in other languages. It's just a lot harder. I don't know. It's not a lot harder to tell it's a memory error, but it's more like logical errors. So you're assigning references instead of making deep copies or something, which is still technically a memory error. It's just, yeah. Yeah, you can do that in C#. Yep. You can have worse problems with memory in C# too, I think, because they let you do some low-level stuff. Yeah. Okay, yeah. Cool. But I think the problem is in here. So when we increase y, we don't resize. Which, you know, that would probably be a good idea to resize when we increase the y too. So you say current y plus line height times PNG output width. Oh, wait, no. I think what's happening is I need to set line height to 0. Okay, let's try this again. So we hit that breakpoint. Nope. Okay. Oh, this one just said debug assertion failed, though. Wait, what's it saying? Oh, wait, no. Vector subscript out of range. Again. I wish it would actually like break my program before it just completely fails, so that I could see which line it's breaking on and stuff. But okay, I gotta think critically about this. So we've got width, height, we got channels. This is the width and the height and the channels of the image we just read. We force it to be 4 channels big, so we know exactly how many channels we'll have. Then we say if the height of this image is greater than the line height, which should be 0 on the first go round, so that's fine. We set the line height to this new height, and then we resize that we should have enough pixels in memory to handle this. So we say current y, which should help us if we're like moving down the image, right? So if we're down here, then it should give us like that current y plus whatever the line height is. So we should get down to here. That should allocate memory up to this point, right? Because of that. Maybe I should be doing current y plus line height plus 1. It might be an off by 1 error. Let's see if that fixes it. Oh man, it was an off by 1 error. Okay. And then we get a null pointer. Okay, so then we're just miscalculating this guy. So we say current raw pixel is y times width plus x. Does that sound correct? And then we're getting null pointer. No, it is not correct because we're forgetting to multiply by 4. Y times width times 4 plus x, which I think that would make it worse, but yeah, I can't reserve though. Because if I reserve, see, this is the problem that I was encountering, right? Because we don't know how big the final output image will be, so we're sort of guessing. So what I have to do is I want to allocate as little memory as possible. So I basically just want to allocate 1 row at a time. And then as I'm going, I get more memory and then more memory. That way, by the end of it, we should stop here. If we reserve memory, we could make a guess, but then we could be like way off, or we could be short and then we'd have the same problem. So. But yeah, off by 1 errors are great. And I'm still getting this current raw pixel was a null pointer, which is weird. Because we're looping through width and height. And so we're going row by row. That's good. That's what we want. And we're saying y times width times 4. Which sounds right. Plus x. I'm pretty sure that's right. Like, let's look at this, right? So say current y is, we're inside this small image. Say current y is here. So we say y times width, which would be, width is like, say, 10, right? And so current y is 3. And I'm doing this by mouse. That's why it is really bad. But okay, so then this would be 10 times 3 is 30. And then say we're here, which is 2. So that would be 32. Which if we were counting pixels, yep, that would be 30, 31, 32. Okay. That sounds right to me. So y times width times 4 plus x. And we're doing times 4 here because we have 4 channels. But we're getting a null pointer. And it says we're getting a null pointer here, I'm pretty sure. Let's run this one more time. Yeah. Oh, I'm in debug. Okay, let's see what this says. So this says current raw pixel is null. We are on 0, 0. Oh, okay, so it looks like we just got bad data. I think that might be because we actually are running out of memory. I'm forgetting to free the memory, right? Okay, so we should be freeing this stuff after every image. STBI free. No, that's wrong. He has it somewhere in his documentation. Actually, I probably have it in texture. Yeah, texture CPP. STBI image free. Okay, I was forgetting to do that, which might be why we were having some problems. So we'll just pass it this. Okay, let's see if that works. Because that could have been an out of memory issue. Nope, okay. So we're on x0, y0. This is just null pointer, so something failed. Oh, it's okay. Check your logs, guys. I always check the logs. So it failed because we're trying to open up MC Meta. We don't care about the MC Meta files because those aren't pictures. So let's modify this a little bit. Okay, so if image dot extension, can I get the extension? Come on, path dot extension. Okay, cool. Dot C string. So we'll do a string compare on this. So we'll say if string compare that and PNG. So if we have a, I think we need to do dot PNG. So if we have a PNG file, we'll increment the files. That way we're just counting PNG images. What's wrong with this? Oh, I guess this should be string dot C string. Yeah, I don't get why they designed this. If you do C string, that should get you a string. Why do we have to do this? I don't know. Library creators are weird. How's it going, Asher? Just saw you pop up in the chat. Okay, so we're fixing bugs right now because I made a lot of mistakes. Okay, in here, we're basically going to do the same thing here, except I'm going to do the reverse. If it's not 0, then we'll just continue. Okay, that should skip all the bad files. Okay. It's running, guys. I think it's actually doing something. How much memory are we using? Okay, we're just using 2 megabytes of memory, and it's... Oh, okay. I wasn't actually running anything. So we're going up to 86 megabytes of memory. So we peak at about 113 megabytes, and for some reason, we're not freeing that memory, which I think is just because we're storing that all in the list. Okay, let's see if we actually got the image that we were looking for. Heck yeah, guys, it did not work. Yeah, this is, well, actually, it's pretty close. Oh, I think we're just having the same problem where I like... Oh, no, this is weird. Maybe we're close, maybe we're not. Okay, so... This is y times width times 4. I have that wrong. That's probably what's wrong with this. So y times width plus x times 4. Okay, let's see if that fixes it. Yeah, I know some images aren't 32 by 32, and we'll probably have to figure out what the best way to deal with that should be, because those are definitely going to throw some problems. Okay, but this is working. Oh, that makes me happy, finally. So we at least have a giant PNG with all the images on it. It may not be completely packed together, like in the best way, but it works. So I think I'm going to leave it as it is for now, and then in the future we'll try and fix it so that we don't get this type of stuff. Is that right? This looks like, I don't know, I think that's right. But yeah, so in the future we'll probably fix it so that basically we can unwrap these or something. Or we'll have to do it so that it actually places them. So we'll basically have it so that we have a cursor, and then we sort of try and like fit this square into the biggest empty space that can fit it, and we'll just sort of do that type of stuff. But this should definitely get us all the images. Definitely not in the best format, but it gets us the images, so that's good. What is this size, by the way? We should probably check that. Okay, so it's 1.91 megabytes. And it's 844 by 9,728 pixels. So definitely not square. For now, I could just delete the images I don't want, but this is basically what we wanted, right? Okay, so let's go into PNG Helper and refactor some of this stuff. So if we go to utils PNG Helper, we're going to say create a function, pack images. Let's see. Yeah, I feel like, and we should probably call this something other than PNG Helper. Okay, so this will be namespace. Yep, it is faithful. Let's go namespace texture packer. There we go. That sounds good. And then we'll say pack textures. And we'll just leave that uninitialized. So we'll have a texture packer, and that can pack all the textures in a file. So we'll just take in a file path. And this will do the same thing. Isn't sorting them by height a possibility? It definitely is a possibility. And I'll think about this a little bit more. This is like a huge problem in and of itself. Like you can Google it, and there's research papers devoted to packing images. Just because there's a few different factors, right? Because if we sort by height, well, okay, so the big problem is we don't know how big the image is at the beginning, right? Because we're basically just starting and we're saying, okay, grab the first image, which is this. So we have no idea that we're even going to encounter these ones. So we're trying to optimally place these as we iterate through them. And then once we get something that's a little bit higher, so like this one is 64 pixels tall, we would have to basically say find the most optimal place, which actually would be right here because that is the most optimal place at this point in time. But then as we go through, then we sort of mess things up. So yeah, it's a tough problem to solve. But I'll think about it. I'll look up some research papers and stuff in my off time and see if I can figure anything else out. But for now, this works good for us because we don't really care if it's performing optimally right now. We just need it to work. The textures on the sides are cut in half. Are they? Did I mess that up? Yes, you're right. Okay. Yeah, that is true. Is it even getting the right textures too? So the first texture should be the first file that we have inside of here, which is Acacia Door Bottom. Let's see. Oh, wait, I see what's happening. So look, this one goes here and then it goes to here. Okay. Thank you. That was a good thing to point out. So we have a flaw in our algorithm. Yeah, the barrel is overlapping the acacia door. Okay, so what's happening there is it looks like we're just wrapping, which that's weird. I didn't even know that would have happened, but that's kind of cool. I guess it makes sense since the way we're calculating this. But basically what we should do is we should check the width here too. We should do something like this, except, okay. We keep that there. And then right here, we say, actually, yeah, wait, should we do it here? Okay, we'll say int new x equals current x plus width. Okay, and then if the new x is greater than the PNG output width, then we need to move to a new line, right? Right. Yeah. And then we need to also check this. Okay, so we need to do this before we do that. Okay, and then down here, we'll just say current x plus equals width. Okay, I think that should fix that problem. So basically, we were just, yeah, writing stuff the wrong way. So continue. Okay, that worked good. And if we take a look at this. All right, I think that fixed it. Yes, cool. Thank you for catching that. That was a good catch. Okay, so now it's all working properly. That was a flaw in my logic. We should have been checking before we wrap it to the new line to make sure that we're not going to make a mistake like that. Cool. So we have all the images being generated. Now we just want to abstract this into its own function. So I'm going to rename this to, what do we call it? Texture packer? Yep. And then we're going to go into here. And we're going to call this texture packer.cpp. Cool. And then we can go ahead and just copy this, except get rid of that. And I'll say include, what's this in? This is in render utils / texture packer. Okay. And then we can get rid of that. And we can implement this. And then we just want to move all of this logic into there. For now. We'll make it a little bit better in the future too. Okay, so that is all of this. And he's saying that's wrong. We'll fix that too. So we'll basically take all of that, put it in here. So now it's all good voxel riffs. I have it abstracted away. So it's not all in main anymore. That should be a good thing, hopefully. Okay, and then we need file system in here. So we'll say include file system. I'll take that out of main because we don't really need it. And we can remove that. We don't need that anymore. And actually, I could probably change this back to my list because I think that the only problem we were having is I was writing invalid memory. I should probably create a check for that so that this doesn't happen in the future. So we'll do this, and then I'm going to put a using there. Okay, and then we need stbi. So we'll say include stb / image h, and we also need image write. stb image write. Nope, that's wrong. /write. Okay, cool. So we've got no errors in there. Just going to remove that because that doesn't matter anymore. Yep, okay. So this all seems right to me. We'll go ahead and just change this up. We'll say, can remove that. Hash include utils / texture packer. And I'm going to go ahead and move all of this stuff up here. just so that our includes are organized a little bit more. I don't know why I have this twice. Okay, and then that, and if we do texture packer, pack textures, and give it the file path, which is that guy. Paste that, and then we can change this images path equals file path. So we'll just remove that and then use file path here and here. Okay, cool. So if we run this again, this should all work. CPP utils is my own custom namespace. And I think it might not be working still because it looks like we're still, access violation. Writing here. Yeah, so it looks like I still need to do some work on it because it's still not working correctly. But the reason I made it was because I think it's fun, first of all. And then second of all, I wanted to make it so that you could, it basically works on the assumption that you have plain old data objects, which means that I can use like memcopy and that type of stuff instead of having to call constructors and destructors. So that's sort of the rationale behind it. I don't know if it's actually any more performant. I should probably do some tests and stuff, but like I said, I think it's fun. So I just work on it in my spare time. But we'll use the standard since it is more reliable. And that should be good. Okay, so if I run that one more time, we should have no problems. And it's still doing the same thing. Awesome. Yep, cool. So this is all working out properly, and we basically have a way to pack our textures. For now, and we don't even have to write this PNG image out because I could just have this uploaded to the GPU, which maybe I'll do. But we'll have to create some sort of method to basically get like texture coordinates and all that stuff sorted out automatically too. So I'm probably going to wait on that for a little bit. But if we go back into main, this is all looking pretty good. I'm just going to sort of organize the code a little bit more. And get that all sorted out. And I think we're probably going to wrap up this stream pretty soon. So I said I wanted to get the image packer done and other stuff. I wanted to start getting into 3D, but clearly that's not happening. In the next stream, what I'm going to be working on is probably coming up with a method to get texture coordinates associated with these textures and basically set up all the block IDs, right? So that's going to be interesting because we could do it where we basically have block IDs associated with their index in the files, right? So we have assets, images, block. This could be 0, 1, 2, 3, 4, 5. And that's how they all get their IDs. But that would throw a wrench in the works if, for instance, you add in a new picture in here in like an update. Then when somebody loaded it, all of a sudden your textures would all be sort of messed up. So that's probably not the best way to do this. We'll probably have to come up with some sort of dictionary where we manually create IDs for all of these, which that would be really annoying, but I think that's probably the best way to do this. We could have it auto-generate like the initial data and stuff too, so that it just has IDs, and then after that we manually add new stuff. But yeah, so we'll come up with that and then a way to get texture coordinates, and then we'll change this image to, instead of being just pulled directly from the file for like this texture that we're showing, we'll have it use a block ID, and then we'll try and put up a few different blocks, right? So we'll have grass and then a few different things. And once we get that working, we should be in a good position to like start 3D for real. So yeah. And when am I going to stream next? Next week. So Saturdays at 9 is when I plan on doing this. I might do some work in my off time just to clean up this code a little bit more because it is looking pretty messy and stuff. And then like update the GitHub and stuff. But I won't do any big changes because I want to do like most of the big features live on stream so that you guys can sort of see how I work through all this stuff. But yeah. So next week at 9 a.m., I will see you guys again. I thought this was a ton of fun. So I'm looking forward to the next one. Cool. All right, guys. Thanks for watching, and I'll see you guys next week.